Hey everyone, so in this video we'll be solving the increasing array question of the CSES Introductory Problem Set. So we are given an array of n integers and we want to modify it to make it an increasing array, which basically means that every element should be at least as large as the previous element. So like suppose we have 3, then we have 2 over here, which is not what we want. We want at least 3 or a number above 3 to be present over here. So in each move you may increase the value of any element by 1. What is the minimum number of moves required? So let's just take this example. So we start off with 3. So 3 is our current maximum element right now, and then we come across 2, but we want to convert this 2 to 3, so to fulfill this increasing array condition. So how many moves we'll need? We'll obviously need the number of moves we'll need is the previous maximum element we had, which is 3, minus this value 2, so which is 1, because let's say the number was 1, then in the first move we would make it 2, and then in the second move we would make it 3. So instead of like making a loop or anything, we can just directly subtract the values. So this becomes 3, and then we come across 5, and 5 is greater than or equal to 3, so we are fine with it. And then we come across 1. Now 1 is smaller than 5, so again what we'll do is we'll add to our moves answer this difference, which is 5 minus 1, which is 4. So we add 1 from here and 4 from here, which is 5. And then we come across 7, and 7 is greater than or equal to 5, because we had converted this to 5 in the previous step. So that is also fine. So again our output will be 5, because 4 from this and 1 from this. So now let's try to code it, and I'll try to explain as along side coding it. So first the input format is n, and then an array like this, so int n and then c in n. And then now what we can do is, as the number starts from 1, we can have our maximum element as 0, so we tackle edge cases, and also the number of moves we have made till now are 0, and then we can take these inputs. So for int I is equal to 0, I less than n, I plus plus, we'll have a variable x, and we'll see in this. And now we can compare if our maximum element is the maximum itself, or is this new element. So in this case mx changed to 3, and then in this case mx stayed as it was because 3 was the maximum element. In this case again it changed to 5, and so on. And now what we have to do is, to our moves we will basically add the difference mx minus x. Now let me explain how this works. So when we came to 3, nothing happened, because our max was 0 and our scanned element was 3, and mx also became 3. So mx is 3 and our current element is also 3, so it basically added 0 to it, because we don't have to make any moves right now, because it's the first element, right? Like we don't have anything to check on its left whether it's increasing or not. Then we came to the next element, and now here the maximum remained 3, but our current element x was 2, so we added this difference 1, so our moves became 1. Now our maximum element is still 3, right? So we don't have to modify the array. That's the best part about this solution. And then we come to 5, and now 5 becomes the maximum, and 5 is also the current element, so we don't add anything. So that's how it tackles these increasing cases. And now we come to 1, and our maximum element is stored as 5, but x is 1, so it adds this difference 4, and now moves become 5. And now 7 is increasing, so 7 becomes the mx value because of this, and x is also 7, so it adds nothing to it. So that's how it works, and we can check this. And oh, I didn't print the value, and as you can see it gives the correct output, so we can just submit this, and this should work. Yep, it passes the test cases.